few people who will drift in as we begin. So morning, I'm Tim Sharp. I'm one of the theme leads for the Future Urban Ventilation Network, so I'm chairing this session. I won't say very much more than that. I'm going to hand over to Simon Jones. Simon, I've known for some years now, an expert in all things ventilation and more recently data. So I'm just going to hand over. Simon, are you okay to share your screen? Make sure it's
yeah, absolutely. Yeah. I hope everybody can hear me. So good afternoon, everybody. I think we're just into the afternoon. I see some names I recognise already, so good to see you again. I've been in the built environment now for probably 20 years or so, most recently more concentrated on ventilation and indoor air quality, and specifically in the last year, interestingly, a real focus on data from the built environment, again, particularly focused on indoor air quality and some energy performance. So the talk I'm going to give today, because I'm not sure of the crowd here, is going to be quite general, but the theme of the conversation and presentation is around the digitization of the built environment, as I see it from my perspective, from the commercial field, and how do we answer the what next question. And what do I mean by the what next question? Well, it's when you have data from the spaces that you manage and occupy, and they tell you certain things, how do we productize that? What do we do with that data to make it meaningful and useful so that we don't end up with thousands of little white boxes sitting on walls all over our built environments in 5 years' time, and everybody wondering what they ever did and did they provide anything useful? So it's going to be quite a broad conversation around the built environment in general, but particularly the workplace and housing, and have a look at how that industry is moving from that perspective. So without further ado, and trying not to screw it up, I will share my screen.
Just while Simon's doing that, if anybody has any questions, if you just put them in the chat for now, and then we'll have a chance for Q&A at the end, and we could just do the normal raising of hand things, or I'll try and pick up anything which has been put into the chat. Thanks,
Tim. And could you just confirm that you can see the presentation?
Yep, no, I can see that all very clearly. That's great. Off you go.
Has it moved on?
Yes, that's fine. All good.
Great, thank you. Okay, so it seems to be working, which is always a good start. So again, my name's Simon Jones. The talk today is predominantly going to be around the digitization of the built environment and how do we answer the what next question. So I'm just going to talk very briefly, because I know there's a lot of air quality people on here, about why this stuff's important, the indoor air quality in the places that we live, work and learning, and the impacts on our health and well-being, just to frame the conversation. Look at the digitization of the built environment, some of the spaces that's happening at scale and those that are not, and then start to think about the what next question and pose some questions about how we tackle that. Beyond academic study and beyond the world of academia, where we're interested in quite granular detail on things, how do the users of space start to use that data in a way that it continues to be useful in the long term, and then bring it to a summary and a close. So indoor air quality affects us every day. This isn't just about data and an interest in pollutants. These things have real effects, and to take just a couple, radon as an example, can be linked to 300 cases in Ireland and over 1,000 cases in the UK directly for lung cancer from our homes and our workplaces. According to Asthma and Lung UK, 5.4 million people currently live with asthma in the UK, and this is a disease we know is significantly exacerbated by indoor environments. And this comes at a cost. Every 4 minutes, someone's admitted to hospital with asthma in Ireland. And this is a country of just over 5 million people. Every 4 minutes, somebody is taking up space in a hospital with asthma. And that disease alone costs the UK 5 billion sterling a year to manage. So these things come with a very, very real cost, and no more so than the human costs. And you can't really talk about indoor air quality at the moment without the context of the death of Ella, a 9-year-old girl in 2013, as a direct result of air quality in her local area, and now Abhishek, a 2-year-old boy who died in 2020 as a result of the environment that he was living in and the direct impact on his asthma. And these tragedies are hopefully starting to frame the impact of air quality in the UK at last. And we are seeing very meaningful changes happening, particularly in housing and the enforcement of standards through the likes of the Housing Ombudsman and the regulator for social housing. We know many of our buildings do not perform as intended. We all experience them every day. And poor indoor air quality costs us every day, not just through ill health, but through performance of employees, absenteeism from school, and now this pandemic has brought into stark perspective the impacts ventilation can have on disease control. It's time for a significant shift in how we as businesses and professionals in the built environment view the air we breathe, and start to value it in the same way we value the water we drink and the food that we consume. There are rules, of course, and this is just one example from Irish health and safety regulations that require employers, for example, make sure sufficient fresh air is provided in enclosed places of work. And health and safety at work regulations are very similar across Europe. They're quite grey box regulation in their type, if you know what I mean by grey box. It's a very broad statement about providing good and sufficient air quality for people. They often lack detail, but they do suggest that ventilation of enclosed workplaces should be considered as part of a workplace risk assessment. But if I was to ask people to show their hands in this talk, who's ever experienced a workplace health and safety assessment of their ventilation, outside of COVID, that is, I bet there wouldn't be that many. But things are changing and we're starting to see real impacts on the ground. And one example of that is in Ireland, we're going to have a code of practice for indoor air quality. And that will be guidance that aims to provide practical guidance on improving and managing indoor air quality in the workplace, specifically to employers and employees on improving indoor air quality and providing them a route to complain if they have concerns, on improving ventilation in workplaces and establishing a set of acceptable values for specific chemical and physical parameters, and describing mechanisms to identify and evaluate the control of these indoor issues. Now, this code of practice, currently in draft form, is due to be released any week now, and that will require any workplace that has people in enclosed spaces, from offices to schools, classrooms, you name it, will have to perform a ventilation risk assessment. If that ventilation is naturally ventilated, then they'll have to monitor those environments. If it's mechanically ventilated, they'll have to demonstrate that it's meeting guidance like CIBSE, for example. So things are slowly starting to change. And talking of CIBSE, of course, there's phenomenal guidance out there if you choose to look on how to ventilate our built environment. CIBSE is one example, has very detailed guidance on ventilation and ductwork and environmental design. They've produced some phenomenal guidance through the COVID-19 pandemic on how to improve those systems and continue to update things like TM68, monitoring indoor air quality, monitoring indoor environmental quality. And of course, regulations continue to update and change. A good example of that is ventilation in Ireland in 2019, changed so that all new ventilation systems in a residential setting had to be independently inspected by a third-party validator. And of course, now increasingly, we're starting to see benchmarks and standards outside of regulation and formal guidance, the likes of BREEAM, LEED, WELL, RESET, FitWell, air-rated, the list goes on, of standards that are increasingly focusing on air quality and health and well-being. And these can have really positive impacts on our built environment, not just in the workplace, but increasingly those standards are creeping out into non-workplace settings like residential. As part of these standards, particularly standards like WELL and RESET and FitWell, we start to see the digitization of that built environment. And if you go into any three of these buildings I have here on screen, one on the left is the Shard, obviously. We have the Accenture buildings in New York and the recent headquarters of LinkedIn in Dublin. These spaces are all top-end buildings, and as you can imagine, are digitized in every corner, not just from an air quality perspective for ongoing monitoring against standards like WELL and the annual detailed checks of air quality, but everything from how people move through the building, their individual thermal comfort requirements, how they occupy space efficiently. Digitization in this environment is really moving quickly and having really profound impacts on the performance of those buildings. The reality is, though, this isn't most of our built environment. Most of our workplaces are a very, very long way from those types of buildings. We occupy former schools. We have temporary accommodation that somehow became not temporary over the years. We have offices above warehouse, offices in purpose-built industrial parks that were built predominantly to bring business to an area or to provide tax loopholes for those that were building them and not built for delivering decent performance. We have whole generations of people working in offices above shops that were originally residential settings, and the list goes on. I'm sure we've all worked in environments, and some of us are probably sat there now in low slung ceilings with ceiling tiles, poor ventilation, light that gives you a headache. You know, this is the experience for most people of our built environment. But arguably, this is where the biggest impacts can be made. And we're increasingly seeing the digitization of these spaces with the advent of IoT technology. So technology that's able to communicate to the web cost effectively and provide fairly decent background information on the performance of those buildings. They're a challenge because they have less space, so they tend to be more densely occupied, little to no HVAC systems. If they do have controls, they're often very basic, and they're undergoing constant fabric improvements and refurbishments over the years. And when we look at these spaces, we can see very poor outcomes very commonly. The graph at the bottom of the screen there is literally taken from a few days ago at a office premises in the centre of Dublin, and people in that environment have been sitting in 2,500 to 3,000 parts per million of CO2 for very long periods of the day, and complaining of poor health and outcomes as a result. And the assumption was it was poor lighting and some other things, but clearly there's some significant issues with ventilation in that space. And of course, our working environment is changing. I don't think any of us have missed how this new hybrid revolution of work has changed how our workplaces have changed. And meeting rooms and collaboration spaces are critical in this modern workplace revolution. They're the points at which we bring people together to collaborate. They're the places that we're now trying to attract people back to the workplace. Otherwise, they might as well just stay at home working on their own. But they represent a particular challenge when it comes to managing air quality and other things, as the numbers of people that use those spaces are very irregular. And we all know that if we have an office space that we frequent these days, Mondays are very quiet, often Fridays are very quiet, meeting rooms can be incredibly busy when everybody's in, absolutely desolate when nobody's there. But there can be some of the places where most of the critical decisions in the workplace are made. They're where the board meetings happen, they're where the accounting meetings happen, they're where crisis meetings happen, product development meetings happen. And if we don't get these spaces right, there is a direct line that can be drawn between the performance of people in those spaces and the bottom line of the workplaces that they're working for. And again, a little bit like the previous slide, I don't know how many people have a meeting room that looks like the one on the screen there, but that's not mine and most people's experience of meeting rooms. Most meeting rooms were often created long after the building was originally commissioned. They've been partitioned off from spaces and systems over time. And look, we've all experienced these spaces. They're where decisions on use boils down to falling asleep in a stuffy, overwarm space or suffering the noise and challenges of opening doors and windows. And they can be incredibly difficult to fix. Trying to upgrade or manage HVAC systems in spaces that have been partitioned off can be incredibly costly and difficult to do. And it's where we see most of the problems, actually. 80% of the spaces we monitor in Ambisense, from a workplace perspective, the places we see problems are these meeting rooms. And the challenge on fixing them really boils down back to the classic hierarchies of controls. Once you've identified a lack of ventilation, how do we go about fixing these spaces? Can we apply some engineering controls? Sometimes we might be able to adjust a HVAC system or a ventilation system to adjust more air, if that's even possible. Increasingly now we're seeing the use of air cleaners being used in those spaces to supplement a lack of ventilation. We might be able to provide some administrative controls into those spaces, manage how those rooms are booked and for how many people. And that's something that data and the digitization of these spaces can do very well. A good example of that is within Ambisense, the company I work for at the moment. We use CO2 decay and other metrics to understand ventilation performance in spaces, and we can use that data directly to impact when and how air cleaners come on, and also how those rooms are booked and used. So if we understand the impact of 8 people in a particular space, that space can be left fallow for half an hour before the next meeting, and that can be forced into a room booking solution so that that space has time to recover properly before the next tranche of people move in. Or it can block a certain amount of people from using that space if it understands that that meeting is going to go on for a period of time where CO2 is going to deteriorate over that period. Because without these kind of controls, we're back to PPE, and I don't think anybody wants that. And of course, when we talk about our workplace, we're now in this working from home revolution, and it's not going to change anytime soon. They estimate that 22% of the workforce in America is likely to be working remotely by 2025. That's 36.2 million Americans working in a home environment. Closer to home in Ireland, the Talent Summit of Employment survey suggested that 26% of the workforce is currently working full-time in the office, and 44% working full-time remotely, and the rest hybrid. And when they question those people, most believe the balance for working at home provided a positive impact on their health and well-being. But this sits completely against what we understand about the performance of residential homes. Anytime throughout Europe we look at standards and air quality in a residential setting, we see widespread non-compliance with even meeting minimum standards. And this presents a particular challenge. The reality of the home working revolution is complex. Managing air quality and employee health and well-being by extension is going to be equally complex. There are people starting work today in the same rooms that they went to bed in last night. There are people working under stairs and in box rooms and on the kitchen table, in spaces that every time research looks into this environment in any detail, finds widespread problems with compliance with even minimum standards and poor ventilation outcomes. And this presents a particular challenge to employees, because large swathes of our workforce are now in environments we have little understanding of or control over. And from an energy perspective, currently we're now offsetting those emissions from the workplace to emissions from home. So there's an amusing saying within the workplace environment that you hear people talking about half the space, twice the experience. The reality is that the workplace environment is shrinking to take account of this hybrid revolution. And all that's happening is we're offsetting scope 1 and 2 emissions into scope 3 at home. So probably the biggest challenge from a health and safety perspective is trying to understand how we manage such large swathes of our workforce in environments we have very little control of. And interestingly, data is starting to feed into that. Ambisense at the moment is currently on a really interesting project in Greece with Cisco and WebEx, where they're combining indoor air quality data from the home working environments and indoor air quality and environmental data from the workplace environment, and providing nudges and information to employees to make decisions about when and when not to go to work, when and when to open a window at home, when to take a break, what the environmental and energy impact is going to be at staying to home today, when you're going to have to air condition your home workplace as well as your workplace, and so it goes on. So there's huge potential in that space. And that brings us on to residential. So predominantly here I've been talking about the workplace, but we're seeing enormous digitization of our homes as well, both in an ad hoc way with the advent of smart thermostats, heating systems, air quality monitors and other systems, all now are starting to digitize and bring that data online. And there are already some very good what next questions, or certainly some usefulness to the data being produced from that space already. We can track fuel poverty quite effectively from how people decide to heat their properties. We can understand if properties are vacant or void earlier, making it more cost effective for housing associations to manage those spaces. We can start to see the drivers of condensation, damp and mold, not just that a space is being kept a bit cool or that the relative humidity is high, but increasingly now companies are starting to break that down even further and look at things like vapor pressure differential, time to heat and time to cool, and all sorts of other parameters like CO2 that provide some insight as to what the drivers of that problem might be. And of course, energy performance. We can see how long it takes to heat a building, how long it takes to cool, and start to infer some very basic information about how efficient that property is, and at least enable social housing providers to focus in resources on the properties that are going to need the most help first. And increasingly, all sorts of other risks are being managed as well. For example, the monitoring of fire alarm systems. And in retrofit, increasingly now, we're seeing data from the built environment being used to validate some of that process. If you're spending 20, 30, 40,000 euros or sterling upgrading a property, having data coming out of the built environment to validate that work is enormously helpful. It enables us to target interventions more effectively, manage risk, and identify the performance of those properties once retrofit has happened. We're working on projects at the moment where we're not only monitoring environmental conditions, we're monitoring energy, water usage, the amount of hot water, the efficiencies of heat pumps. Almost everything is possible. And increasingly that data is available anyway. So you'd have been doing this 5 years ago, you'd have been putting in 15, 20 sensors to get that kind of information. Now heat pumps are connected to the cloud, PV systems are connected to the cloud. We're getting smart energy meter data being fed in. Increasingly now as an organization, we're the glue in the middle that's pulling all of this data into one source and producing tools for the people that are doing work on those buildings. But we still have to answer the what next question. So I have a condensation, damp and mold risk. Great. What's next? You know, I feel that this proportion of our stock is less energy efficient than the other. What next? Data only has value if you can productize it. Beyond, again, the academic side of these things, we have to be able to do useful things with data that makes that product sticky over time, that those sensors don't just become obsolete. Batches run out, sensors get put in drawers, and people wonder what it ever did. And a good example of that is if we take something like condensation, damp and mold, we know that we can understand quite a bit from fairly rudimentary temperature and moisture data from buildings about what's going on. We can unpack, is it temperature driven? Is it relative humidity driven? Are we vapor loading a building? Are we cooling and heating surfaces in a way that's going to be problematic? There's a whole bunch of stuff that we can do from that data that can produce quite quite useful tools. But the reality is something like moisture balancing buildings is a complex piece. I've just listed off a few of the drivers of moisture balance here, from systemic to building fabric to use to contextual, like fuel poverty, for example. And those are leaks, cold bridging, poor insulation, building design in of itself, lack of ventilation, poor zoning of the building, poor heating controls, lack of heating generally into a property, high density of occupation, poor heating and ventilation use by occupants, direct system interference, blocking of vents, turning off of fans as an example, and lack of knowledge of how to use these systems. And anybody that's in this space knows that moisture balance is a delicate thing to get sometimes. And when you change one thing, you can have a knock-on consequential impact on something else. So how do we create tools from that data that we're collecting that can unpack it in a way that enables organizations to deal with something like moisture balance? If you're a housing organization, there are multiple departments, systems and channels that interact with a range of these solutions. You might have housing officers, you might have kitchen replacement programs, you might have boiler replacement programs. You might have specialist teams that are set up to deal with condensation, damp and mold. You've got CRM systems, you've got phone systems, you've got feedback, community programs, public relation, external affairs. These are complex organizations, and you don't win the battle of condensation, damp and mold in housing without correctly managing all of those systems and bringing it all to bear on the problem. So how does data focus resources in those environments? It's not enough just to say a property has a problem with damp and mold. We have to understand what to do next with that data set. How does data action actual interventions? And how does data improve outcomes or reduce liability, as an example? So I've actually whistled through this, but what's next? So the challenge with this data, as I see it predominantly, is we've got to start connecting the dots between resources. The challenges at the moment is that the built environment is being swamped with data. There's data lakes being created and nobody really knows what to do with them. And particularly for bigger organizations, it's one of their big challenges at the moment is bringing in the capacity and the knowledge to understand how to deal with these data sets and pull them all together. We're not very good, although you hear it talked about all the time, of developing actionable insight from data. Beyond ziggy-zaggy lines on a screen that I find interesting and can geek out on, we have to create tools and outcomes from data that are actually generally useful for people. Otherwise, these systems will just slowly erode over time. And we have to develop the systems beyond the data to manage it effectively, because data without purpose is just more noise. And increasingly we're seeing that is you may capture some champions within an organization that take an interest in building physics or outcomes from damp and mold or health of workplace environments. But if those people go and you lose them or they move positions, you find very quickly that that interest in the data erodes. And next year, when people come to renew software programs or platform programs, you find it doesn't happen. And all of a sudden that system has deteriorated or vanished. So the point of this conversation is to say that data from the built environment is proliferating across all facets at the moment, enormously quickly, both from an academic level, both from a policy being driven by a policy level, but also at a commercial level. There are an enormous amount of businesses now selling into this space. The question is beyond the interest of dashboards and screens and ziggy-zaggy lines, what do we do with the data that is meaningful from an outcome perspective? That's it. Thank you very much. What I'll do is I'll stop sharing. Are there any questions? Anybody?
Great, thank you, Simon. Yeah, really, really thoughtful presentation. That's excellent. Right, yes, so we have some time for some questions. I shall look for people to put their hands up if you want to do that. Oh, right, well, and in fact, some in the chat as well. So, Corinne, do you want to speak your question, or do you want me to read it out?
Hello, I can read my questions. Hello, Simon. It was a very nice presentation. It's very interesting to know that there is a building code, an IQ building code in Ireland to be released soon, if I understood correctly. I have two questions. What is the frequency of the ventilation control? Is it every year or every 2 years or 5 years? And why have you not planned some IQ measurements?
Yes, so the code of practice for indoor air quality was driven politically following the COVID pandemic. So some opposition parties wanted to try and create some protection from employees in the workplace, and it found itself in its natural home of the Health and Safety Authority in Ireland to come up with a solution. The code should be released in the next 2 or 3 weeks, is my understanding. It's imminent. It's available still. If you Google indoor air quality code of practice in Ireland, you'll see it. It's there, and it's a mixture of some basic information on air quality and health and well-being in the workplace, generally for employees. It's practically a two-pronged approach to managing air quality. If the workplace is naturally ventilated, then the guidance moves towards monitoring indoor air quality from a CO2 perspective and provides some guidance on how to do that. If the workplace is mechanically ventilated, then it very heavily directs them to things like SIBSI guidance, 10 litres a second per person, all the kind of numbers that we're used to hearing. The difference being is, and to answer your frequency question, and I don't know, but it will sit within the frequency of most health and safety codes of practice, which are annual risk assessments that you will include as part of your fire safety risk assessment, your warehouse risk assessment and everything else. And the risk for employees would be at some point a health and safety inspector turns up and goes, can I have a look at your warehouse risk assessment, please? Yeah, very interesting. Can I see your ventilation risk assessment, please? And you'll now have to have that. So, and there's guidance on how to do that, and it will ask very specific questions. And my feedback from industry so far has been that's going to be a real challenge for people, because nobody's ever asked for an annual inspection of the ventilation system where you've had to guarantee SIPC levels of airflow rate into each of the workplace zones, as an example. Yeah, those systems may have been commissioned when the building was built, but the reality is that the most maintenance will have been checking the fans still work and aren't making a noise, and that there's not an alarm code somewhere, or that fire dampers are still operable. But nobody's ever really gone back to the workplace and says, is this room of 5 people delivering 50 litres a second? That's not been done before. So I think that'll be very interesting, and I think it will really concentrate minds. And what hasn't been picked up, I don't think, is it's any occupied workplace. So that includes classrooms, our workplaces for teachers, for example. Workplaces are offices, but that's not just your LinkedIn headquarters. That's your office above a shop on the high street. That's your cafe, you know, down in a basement. That's every workplace will now have to think about those kind of standards. So I think broadly it's very positive.
Okay, thank you. And about measurement, why is it not mandatory to measure CO2, for example, as it is now in Belgium?
Yes, so basically, if you can't guarantee the flow rate with mechanical systems to say it's delivering that kind of guidance rate, and to be fair, if you're delivering 10 litres a second per person, ventilation's air quality is probably going to be reasonable, depending on where you're drawing the source from, of course. But most spaces in the built environment are mixtures of natural or hybrids of natural and mechanical systems, and they're inevitably going to have an air quality sensor in each of those spaces. There is one small loophole, and that is that what they call a simple space, which we believe is one person in a one-person office with a window. They're not expecting that to be monitored, but anything beyond that, it looks like you'll have to monitor from at least CO2 anyway.
Okay, thank you very much.
Thank you, Simon. Can you see the chat? Because there are some questions in the chat.
Yes. One from Dave. So one of very many issues with ventilation control in new or redeveloped buildings can be the conflict between openable windows and noise, where the ventilation and/or heating assessment include consideration for windows to be open for purge ventilation, but this could then result in sound levels in the dwelling exceeding the British standard or deemed as a statutory nuisance. Are there any suggestions or considerations for this? I don't really have an answer for that. It speaks to what I was talking about with the meeting rooms. You know, people are often faced with a binary decision of providing some fresh air or air into a room and opening windows and dealing with thermal discomfort and or noise. And I was only having a conversation this morning about overheating in apartment complexes in Dublin, and one of the challenges there being people don't want to open windows because of traffic pollution and noise. So it is a problem. Interestingly, we're starting to see the proliferation of noise monitors within sensors. They're very cheap and can provide actually reasonable decibel data. It can be surprisingly good from what I understand. So increasingly now we're seeing data embedded within indoor air quality and environmental condition data of noise data and light. So that you may well find there's a data set there that starts to back some of that up and may create some changes.
Which is interesting, because it may back it up, but it may also refute it as well.
Yes,
there are certain, with some of these things, there are certain preconceptions that people might have. For example, about outdoor pollution, people hear a lot more about outdoor pollution and are more aware of it, even though it is variable. So that's an interesting problem.
Yeah, indeed.
It's where data becomes important, and I might come back to a question about that, but I'll let you answer the other questions first.
It's really interesting point, Tim, and actually, you know, we often view things through the perspective of our climatic conditions where we are as well. I've been having numerous conversations with people in the tropics, for example, where decisions about when you open and shut the fabric of the building, it can have dramatic impacts on moisture loading of that space, depending on the time of year or comfort levels, and that we don't often have to factor in here. So that the assumptions are driven by completely different factors to what we have here, which is quite interesting. Kate Senko asks, Simon, when a client comes to you for monitoring sensing help, do you find they tend to be prepared to take the needed action your data suggests? I've informally encountered some landlords, for example, who are happy to have monitoring, but don't really grasp what is needed to supply good ventilation beyond replacing broken extracts, and educating tenants, open brackets, close brackets. Thanks, Kate. That's a loaded question, if ever there was one. There are, it's the what next question, isn't it? You know, I think a lot of this is how you frame data from the built environment. And obviously I come from a commercial space where we don't want to frighten people off from the data either. And the reality is, outside of the extreme cases, and I'm careful when I say extreme, because there's a lot of people living in very poor conditions, a lot of our built environment is fine, broadly speaking. And sometimes we forget that. And actually, sometimes it's as much about what's going well as it is about what's going wrong in the built environment that data is useful for, because it enables you and frees you up to focus your resources where it's actually needed. And that applies to both the workplace as it does the residential setting. So often when we're talking to people about the need for data from the built environment, it's to put them at ease that actually, if you're doing a representative sample, often a lot of those spaces are broadly okay, can be improved with nudges. Sometimes they're social, sometimes they're physical interventions, but it's not a catastrophe. But it enables you then to focus really down on where you need to fix those problems, and to recognize from any organization's perspective that time is running out anyway. Within the next 10 years, we will all live and die by the ongoing performance of the spaces that we occupy. Whether you're a regulator, a housing authority, a brand selling into that space, you will be judged by the ongoing performance of that space, whether you like it or not. The choice right now is whether you take control of that process or not. And I'm increasingly seeing litigation being brought by private homeowners and organizations and employees, where they take this into their own hands. If you own a workplace at the moment, there's a good chance several people have an indoor air quality monitor on their desk, you know? So it's happening anyway. It's always about creating these links. For me, we've always had a problem in the air quality community. I think that people understand that poor air quality is bad for you, but we've been terrible at joining the dots between health outcomes, air quality, and systems that provide the air quality, joining those dots. And I think what data is enabling is those dots to be joined. And importantly, if you're spending money, seeing outcomes. And that's I'll just make this, because this is a really interesting point. condensation, damp and mold is not a problem that will be fixed next winter, but the expectation is being built at the moment that this is a problem that needs to be fixed. And anybody that's embedded in condensation, damp and mold problems in housing knows this is a problem well beyond being fixed this year or even next. So what happens next winter without data? Well, next winter, what happens is some properties will have ventilation upgraded. Some properties might have some of the fabric upgraded. There might be some lessons and education for tenants on how to manage spaces better, all done very carefully now because the dial has swung from blaming the tenants to sorting the problem out. But when that problem inevitably isn't fixed next winter, when damp and mold comes back, because replacing the ventilation is unlikely to fix all of those problems, that trust starts to be eroded. But if you have data from the built environment, you can point to the impact of that intervention and go, yes, we've started to fix the problem, and that's the tangible impact of that intervention. And next we're going to do this, and next we're going to do that. And you can track the pathway towards ultimately success. But without that data, what happens anecdotally is people see interventions in their properties, it's interfering, it's dirty, it causes dust, they might get annoyed, and then the problem comes back in some form or other next winter, and they now don't believe that you know what you're talking about. So data is going to be incredibly useful, I think, as we start to do things like that, fix these problems. Debbie said, who would be best placed to lead the way in using the data for change? So housing providers, owners of portfolio of spaces, educational estates, and what are the drivers to make this happen? It's a really good question. That I think it really depends on, in business speak, you'd call it the vertical. So in data in the built environment, there's several verticals. One of them is education, one of them is residential, one of them is workplace. And the drivers for each can be fundamentally different. And the reasons people don't act in that space can also be markedly different as well. For example, education in the UK really started to focus in on indoor air quality this time last year. It was a second winter of sitting in cold classrooms, being forced to hold windows open, trying to keep, if you had a CO2 sensor, trying to keep it below 1,000 parts per million and the temperature above 15 degrees. So minds were concentrated. But in that vertical, that summer, teachers had renegotiated their salaries. So schools coming back in September of 2022 had a wall of costs facing them for September. And then on top of that, they had the fuel poverty crisis hit them. I know several institutions in Ireland, for example, had negotiated their energy prices in, I think it was 2017 was the last round of national energy price negotiations. And guess what? The energy price negotiations had come up for renewal in the summer of 2022. So you can imagine the increase in costs there. And I know certain institutions were talking about shutting whole buildings down, never mind trying to understand how to manage energy costs in their buildings. So we had a complete collapse of interest in the summer leading into autumn last winter on monitoring classrooms because, quite frankly, they were frozen by high demands on costs. The housing sector has woken up this winter to condensation, damp and mold, as everybody knows who's been looking at it. And we're seeing very driven interest. At the moment, it's a governance and risk issue, and now a move towards the practicalities of actually sorting condensation, damp and mold out. So it just depends sector to sector. Dave, given they are not approved for monitoring to a suitable standard, is the prescriptive method of ensuring the accuracy and precision of air quality sensors or noise monitors, as you've just mentioned them, being used? Given they are not approved for monitoring to a suitable standard, Yeah, I'm guessing this is pointing towards low-cost air quality monitors. Yeah, I don't know where Dave comes from, but there can be a very different perception of indoor air quality monitoring for practical purposes as opposed to academic and research purposes. That the question has to be that whatever accuracy of data you get out of a product, is it enough to create an outcome that gets a better result? Ultimately, can you productize it in a way that drives an outcome that is of benefit? So the classic example of that at the moment is a lot of interest in PM monitoring. And a lot of standards, whether it's Well Standards Reset, Fitwell, all looking at things like WHO standards for PM 2.5 and PM 10. The reality being, those low-cost PM sensors are absolutely rubbish at monitoring PM levels down at those levels. They're quite useful to see a spike or an event of some description, but you wouldn't want to rely on one to tell you that you are hitting WHO standards for 2.5 of PMs, as an example. So does that mean it's useless? No, not necessarily. If the data is used in the right way, you can learn when events happen, and can you label the data in a way that makes that useful for people to have an impact on it? You certainly see things like fire, wildfires and things like that, but VOCs would be very similar. TVOC sensors are a bit of a chocolate teapot when it comes to usefulness from a data perspective, but they can be quite useful at understanding that every Monday morning you get a big spike in TVOCs because the cleaners are using products. You don't know what was in those products from the TVOC data, but it doesn't mean that can't create an action for somebody to go and investigate and maybe change a policy or protocol for what kind of cleaners are used. It's a really interesting one, that the how you frame low-cost sensors, and is the data useful? Can you do something with it that's of value?
I mean, I'll maybe add something to that, because I think it's, the danger is that perfect becomes the enemy of good. And no, these things aren't perfect, but CO2 is not perfect by a long stretch. It's a really rough indicator. So it's a bit like a windsock. Do you know what I mean? It tells you roughly which direction the wind is coming, and but if you've got enough of it, if you've got enough of those sensors, so if you've got 5 sensors, then the difference between them becomes incredibly important. If you've got 5,000, then it means much less. What you get is a general indication of what's going on, and what becomes more interesting is trends rather than events. So when you see people reporting, PM was 1,473, that's irrespective. It was above 1,000 for a significant period of time on a regular basis. So it gives you that sense of what's going on. That's what Simon just said there. I think that's what's important. And the ability to collect this stuff at scale indoors, I think is really important. We have for many years collected outdoor air quality data, and we've been able to map that onto population health data and make those relationships. We haven't been able to do that on indoor air quality because we only do it in little places every so often for short periods of time. So the bigger data sets are really important there. And so no, you won't have sort of research grade sensors in those situations, but you will have enough to give you a much better sense, A, of what's going on, and B, as I mentioned earlier, that issue of where do you want to concentrate, where is this happening regularly, most seriously, in order to then perhaps go and do more focused.
And look, standards like the Well Standard recognise that, for example, so there will be a mixture of both longitudinal monitoring with low-cost sensors and annual checks for checking, benzenes and formaldehydes and all the stuff you need to do with proper monitoring. So you can do this stuff intelligently, and we don't really fully understand the art of the possible from these big data sets. I know our data scientists internally are only just starting to use k-means clustering and anomaly detection and a whole range of tools that they have at their disposal from a big data perspective to start unpacking the performance of spaces. One good example of that is we've been using CO2 decay in spaces to start to build a fingerprint of the air change performance of that space. We understand that CO2 decay may not be indicative of the in-use ventilation performance of the space. You know, a teacher shutting the windows before they finish the classroom and locking the door and going home. So the CO2 decay you see isn't indicative of the performance of the space. But over time, with enough data sets and understanding the interplay between that decay, wind direction, wind speed, use of the space, matching it to decay during the day and checking gradients, you can over time build quite an interesting picture of how that space performs from quite a simple metric. And that in turn then can be used to create tools to understand gaps in ventilation performance, interact with things like room booking software to manage spaces more effectively. There's a whole bunch of stuff you can do with data if you view it through the right lens and you're trying to generate outcomes. And one of the things that's been really useful for me through COVID has been being forced to see things through the lens of risk rather than academic certainty or data science, to say, okay, you can't eliminate risk, but what can I do everything that reasonably expected from me today to do the best thing to mitigate this risk where possible, and say, are we, like you say, not letting perfection be the enemy of the good? Can we do stuff with the data sets we have at scale to create outcomes that may not be perfect, but improve the built environment in meaningful ways? And I think there's enormous opportunity to do that. And when we start to view it through that lens, it really opens up the what next question, which is ultimately what this is about. Nobody's interested in just sitting there looking at guinea pigs suffocating slowly in classrooms and offices. We actually want to create outcomes for people that improves their lives and their health and well-being. And I think that's the fascinating bit, because it pulls in social science, brings in mechanical ventilation and building physics and all of these things that will actually improve the spaces beyond the data.
Great. That's really helpful. So I don't see any more questions, don't see any more hands going up. Just a last curse round. So, and we have reached the end almost perfectly of our allotted time. So fantastic timekeeping, Simon. Well done. That's really good. Yeah, if there's no more questions, thank you very much, Simon. Really insightful and thoughtful talk. And thank you everybody for the questions. I hope you enjoyed it. I don't know if Helen's here to tell us when the next one of these is, but we'll send emails out anyway. Thank you everybody thank you very much everybody for your participation. Simon, thank you again. Really excellent talk. And we will see you all at the next one, hopefully. Cheerio.